Corrosion is the chemical or electrochemical reaction that causes metals to deteriorate when they react with their environment. Something as simple as oxygen and moisture on a wing skin can start the process. On aircraft, aluminum doesn't show rust in the familiar red way, but the surface can dull, pit, and weaken if protective coatings fail or moisture gets underneath paint or sealants. Preventing or stopping corrosion early is key because once it starts, it can grow deeper over time. Aircraft are exposed to extreme and varied environments: high humidity, salty coastal air, temperature swings, pollutants, and even de-icing chemicals, all of which make corrosion worse. Salt-laden air acts like an electrolyte that accelerates metal breakdown, and humidity and trapped moisture in joints or crevices can create perfect conditions for corrosion to begin and grow. Understanding how weather and chemical exposure affect aircraft materials helps us plan better inspections and protection. Corrosion tends to show up where moisture, contaminants, and dissimilar metals meet: under fastener heads, in lap joints, inside wheel wells, around drainage paths, and where coatings have been scratched or worn. Areas that trap water or salt spray, like belly skins and lower fuselage, also corrode quickly if left untreated. Because some corrosion starts out of sight, inspectors use detailed checklists and sometimes NDI tools to find hidden corrosion before it compromises structural integrity. There are several common forms of corrosion that aircraft technicians must recognize. Uniform surface corrosion, which roughens or discolors metal evenly. Pitting corrosion, where tiny holes eat into surfaces. Intergranular corrosion, which attacks grain boundaries. And dissimilar metal corrosion, which happens when two different metals form an electrical cell in the presence of moisture. Each type has its own visual cues and risks, and learning to spot them early is a big part of good maintenance. Even small corrosion can reduce how much load a part can carry and increase fatigue stress. Pitting and intergranular attack eat away at metal, creating stress razors that weaken structure and make cracks start sooner under cyclic loads. If corrosion isn't stopped, it can cause material loss, structural weakness, and eventually part failure, potentially grounding aircraft or forcing expensive repairs. Keeping corrosion in check keeps aircraft strong and airworthy. Modern corrosion control isn't just about reacting, it's about preventing first. That means choosing corrosion-resistant materials, using coatings like anodizing or specialized primers, designing good drainage and ventilation, sealing joints, washing aircraft after exposure to salt or pollutants, and planning regular inspections. A good prevention program combines material science, smart design, and regular maintenance so corrosion never gets a chance to grow.